Hi guys, this video is going to be our first video in the second unit. This unit is on linear algebra. It's going to be a lot of review. So the title of today's lesson is basically solving equations. Everyone knows how to solve equations, so I'm not going to bore you and go through things that you know how to do. Instead, what I've done is I've chosen some types of problems that people get hung up on sometimes. And so the first type of problem is a distributive property problem. First of all, when do you use the distributive property? Well, you use it when you've got multiplying on the outside and you've got adding or subtracting on the inside. And so also on number 2, we have multiplying on the outside and we have adding and subtracting on the inside. So both of these would be distributive property problems. So I'm going to start number 1 by distributing my 6 to both numbers. That means I'm going to have a negative 30x plus 48 is equal to 168. And then I just solve the problem like normal. I subtract my 48 from both sides, and that gives me a 120 on the right. I divide by negative 30, and that gives me x equals negative 4. Remember, we always should check our answers when we get to the end of the problem. So take out your calculator right now, find your calculator, pause the video here, and check this answer and make sure it works. Okay, you should have been able to see that when you plug in a negative 4, it does work, and the answer is negative 4. Number 2 looks like a distribution problem, and you could do it by distribution, but there's actually a different option. And that option is, instead of multiplying that 2, you can actually divide that 2 from both sides. And so what I'm going to do is I'm going to do it that way just so you can see how it works. So on the left-hand side, that leaves me with a 50. On the right-hand side, the 2's cancel, and I'm left with an 8y minus 6. Now, you might wonder why even do that. And the reason is sometimes it makes it easier. Sometimes if you distribute, that actually makes the problem harder. And so I want to show you that this is an option so that you have that option available when you need it. Okay, now that I have 50 equals 8y minus 6, I'm just going to solve the problem like normal. So I'm going to add 6 to both sides and divide by 8. And so my answer here is 7 is equal to y. Once again, we should check that answer, plug it back in, and see if it works. Over in the margin, why don't you write down, don't distribute if dividing first is easier. That's just a little note to yourself, so that you remember you don't always have to distribute. The other option is you could divide instead. Next concept is combining like terms. We have two different setups. If you look at number 3, the a's, the variables, are on the same side of the equal sign. If you look at number 4, we have an n on the left and we have an n on the right. They're on different sides of the equal sign. And so each different setup is going to require a slightly different approach to the problem. For number 3, we are going to combine like terms. If they are on the same side, you can combine like terms. So we add those and we get a negative 5a. I like to keep my variable on the left, so I'm going to move that 3 over to the other side. And so now when I divide by negative 5, I get an answer of a equals 1. Once again, we want to go double check that answer, plug it in, and see if it works. On number 4, some of you learned this method when you were younger of drawing a line down from your equal side. I'm just going to do that on this one just to emphasize the fact that there's an n on the left and there's an n on the right, and we just have to remember that. And like I said a second ago, I like to have my variables on the left, so I'm going to add a 2n to both sides. So I add my 2n, that gives me negative 1 plus 3n is equal to 5. I need to move that negative 1, so I'm going to add negative 1 to the other side, and I get 3n equals 6. And of course, at the very end, I'm going to divide by 3, and I get 2. Of course, you want to check your answer, plug it in, make sure it works. But the main thing on number 3 and 4 was on number 3, they were on the same side of the equal sign. On number 4, they're on different sides. Okay, numbers 5 and 6 have fractions in them. Most people don't really like dealing with fractions, so there's an easy way to get rid of the fractions. To get rid of the fractions, you multiply by the denominator. So I'm going to show you how this works. And I know that you've seen this before, but this is going to be a refresher for some of us. So my denominator on the left is 5. My denominator on the right is also 5. That makes it handy. That means I'm just going to multiply by 5 over 1 on both sides. So those 5's cancel out. That's how multiplication with fractions works. So I have a 16 on the left. On the right, I do need to distribute this. So I have a negative x times 5. That's a negative 5x. And once again, this 5 and this 5 will cancel out, and we have a minus 3x. Okay, my x's are on the same side of the equal sign, so I'm going to add those like terms. It gives me a negative 8x, and I'm going to finish out my problem by dividing both sides by negative 8. And so my answer comes out to be negative 2 is equal to x. Once again, we would want to plug that in and make sure it works. Number 6, similar deal. You have a 2. Let's get rid of the 2 by multiplying both sides by 2, or 2 over 1. It means the same thing. So on the left, I have an 18, and on the right, this 2 and this 2 cancel each other out, and I get a negative 1 plus n. I'm going to add that 1 to the other side, and I get n equals 19. Okay, I know that a lot of people don't really like fractions. A little quick review, we will have a lot of fractions in this class. You can't really pretend like they don't exist. They are going to exist, and we do need to deal with them. Now, the first 3 concepts all came up with pretty normal looking answers, like n equals 19, x equals negative 2. The ones in this last section, numbers 7 through 10, are all going to have slightly unusual answers. So let's just go ahead and dive in and see what's happening here. Number 7 looks like a distribution problem, so let's go ahead and distribute. All right, so I distribute my negative 7. I get negative 42n minus 21. I like to have my variables on the left, so I'm going to start out by adding a 42n. Now, I will say that that step, you have 4 options. You could add this 21 to both sides. You could subtract that 7n from both sides. I mean, you've got 4 different things you could do. I just chose that one first because I like to have my variable on the left. Okay, so when I go ahead and add those together, I get negative 21 plus 49n is equal to negative 21. Okay, here's my n. I need to add this 21 to the other side to get rid of it. Move it to the other side. I want to isolate my variable. Okay, when I do that, I get a 0 over on the right. That's okay. There's nothing wrong with a 0. Zeros are perfectly legitimate answers. Now, I'm not done with my problem yet, but I'm almost done. I need to divide by 49. And what's 0 divided by 49? It's 0. That's okay. 0 is not a bad answer. It is a perfectly legitimate answer. So that's okay. In fact, if we plug it in to check it, it should work. Let's just do kind of a mental check. If I plug in 0, then I get a 0 for that term. So I get a negative 21 is equal to 0 plus 3 is 3, and 3 times negative 7 is negative 21. Negative 21 equals negative 21. They equal the same thing. The 0 works. So just because you get a 0, don't let that get you panicked or anxious or whatever. It's fine. 0 works. It's okay to have a 0. Let's look at number 8. Once again, looks like a distribution to start. Okay, so I distribute. I want to have my variables on the left, so I want to get rid of the variable over here. So I'm going to subtract that 7x. You do have other options. That's just the option I chose. I get 7 equals 5. I can't really go anywhere from here. I'm kind of done because there's no variables. My variables left me. Okay, does 7 equal 5? No. So what do we write in that situation? That is a no solution problem. And so our answer is just no solution. It's not really 7 equals 5. That's not really part of the answer. It's just no solution. And you might have done this differently and come up with like 0 equals 7 or something like that. It's still no solution. Anytime you get 2 numbers that don't actually equal to each other, the answer is no solution. Okay, this last one, it's pretty basic. 2y minus 2y, that's 0. So we get 0 equals 0. Once again, a little strange, but anytime you get one number equal to itself, then our answer is infinite solutions. So first of all, let's compare these three. Number 7 had n equals 0. This one has a 0, but it's a 0 equal to itself. That's infinite. This one had two numbers equal, but they were different numbers. That's no solution. So those are three distinct cases that are each slightly different from each other, but the answers that I've circled, those are the answers. Why don't you pause the video here, try to do number 10 on your own, and see what you come up with. Okay, on number 10, you should have solved it and come up with 20 equals negative 20. You might have done it differently and had a slightly different answer, but anything that you come up with should be basically two numbers that don't actually equal each other, and that would be a no solution problem. So over in the margin, let's write down a couple things. The first thing I wrote down, that x equals 0 is okay. It's okay to have an answer of 0. It's a valid answer. The other two are the ones that people sometimes get confused. If a same number is equal to itself, that means infinite solutions. And if it's some kind of a false statement, like 2 equals 5, that means no solution. And the last thing I might say about infinite solutions is, what that means, you could plug any number in for y, and it would work. Okay, let me show you what I mean. Let's say we plugged in y equals 0. We would get 0 minus 0 equals 0. That works. What if we plugged in 3? We'd get 6 minus 6 equals 0. That also works. What if we plugged in a negative 7? We'd get negative 14 minus negative 14, or negative 14 plus 14, is equal to 0. Any number that I picked to plug in would work. Those are all the infinite solutions we're talking about, all those bunches and bunches of numbers that would all work in that situation. Okay, we will continue to work on some equations in class. So for now, I do want you to write down a couple things in the summary, a few things you need to remember from this lesson. Also, I didn't mention questions, but if you have questions, remember in the margin, write your questions in the margin, and you can ask those questions in class tomorrow as well.